Lesson 4, Equations and their Solutions. Learning target, I can find solutions to equations by reasoning about a situation or by using algebra. A gram of protein has 4 calories, and a gram of fat has 9 calories. We can represent this relationship in an equation. The equation 4x plus 9y equals 110 represents this relationship. This equation represents a snack that has 110 calories in total from grams of protein and from grams of fat. To solve this equation, we need to find a combination of proteins and fats that total 110 calories. Now let's see what happens when we substitute 5 in for x, where our equation becomes 4 times 5 plus 9y equals 110. This equation represents a snack that has 110 calories all together, but the snack has 5 grams of protein and some grams of fat. Solving this equation means finding the grams of fat that are combined with 5 grams of protein to give us a total of 110 calories. Is the combination of 11 grams of protein and 5 grams of fat a solution to the equation? To find the solution to this equation, we can substitute pairs of values for x and y. First, let's substitute 11 for x and 5 for y. 4 times 11 is 44, and 5 times 9 is 45. 44 plus 45 is 89. In order for the value pair of 11 and 5 to be a solution to the equation, the values need to make the equation true. The equation is true when we have a total of 110 calories. This pair only adds up to 89, so this is not a solution. They do not add up to 110 calories. Let's find a true solution for this equation. We can start by choosing any value for x or y, and then solving for another variable. Let's use 14 for the value of x, so we can solve for y. So this is going to be 14. We can plug that into the equation. X is going to be 14. We're still going to be looking for y. Let's go ahead and simplify. 4 times 14 is 56. 56 plus 9y equals 110. In order to isolate the variable we're solving for y, we can subtract 56 from both sides. It's going to eliminate 56 over there, leaving us with 9y equals 110. Take away 56 is going to be 54. So we have 9y equals 54. Then we need to divide both sides by 9 to get the y by itself. Divide this by 9 over here. 9y divided by 9 is going to leave us just with y. 54 divided by 9 is going to leave us with 6. So for this, we are going to say that x is 14 and y is 6. Now we can check our work. If we plug both of these variables into the equation, 14 for x, 6 for y, 4 times 14 is 56, 9 times 6 is going to give us 54. 56 plus 54 is 110. 110 is equal to 110. Yep, that checks out. So one solution to this equation is x equals 14 and y equals 6. Remember that x represented the number of grams of protein, so we can say 14 grams of protein, and y equal to grams of fat, so we can say 6 grams of fat, total 110 calories in this solution. An equation that contains only one unknown quantity or one quantity that can vary is called an equation in one variable. We can use the equation like 2L plus 2W equals 72. This equation represents the perimeter of a rectangle with L being length and W being width. If the length of the rectangle is 15 units, we can use the value of 15 in the equation in the place of L. Then, W is the only quantity we don't know. This is an equation in one variable because there's only one quantity that is unknown. In order to find the solution, we're solving for W. In this case, 21 is the solution because substituting 21 for W in this equation results in a true statement. We can show that this is a true statement by simplifying the left-hand side. 2 times 15 is 30. 2 times 21 is 42. 30 plus 42 is going to give us 72. 72 equals 72 is a true statement. The solution for this equation is that when the length is 15 units, the width is 21 units. When we evaluate an equation in two variables, we are still trying to make the equation true. An equation that contains two unknown quantities or two quantities that vary is called an equation in two variables. A solution is a number pair that makes the equation true. Let's use this example. Tyler spends $45 on t-shirts, $10 each, and socks, $2.50 per pair. If T is the number of t-shirts and S is the number of sock pairs, the equation is 10T plus 2 and 50/100 S equals 45. There are two unknowns, T and S, with multiple value pairs that will satisfy the equation. This means there is more than one correct solution to this problem. Let's now determine whether given values are solutions to the equation in scenario from the previous slide. First, let's check T equals 3 and S equals 6. These values represent how many t-shirts and socks Tyler bought to spend $45. The value of T equals 3 represents that Tyler bought 3 t-shirts and at $10 each. And the value of S equals 6 represents Tyler buying 6 pairs of socks at $2.50. Now we can substitute these values in the equation. So T is going to be 3 and S is going to be 6. 10 times 3, let's simplify, is 30. 2.5 times 6 is going to go to 15. We can combine the 30 and the 15, and that will give us 45. And 45 equals 45. So we can see that this is a true solution to this problem. If Tyler buys 3 t-shirts and 6 pairs of socks, he will spend a total of $45. There are other pairs of values that also make this equation true. Let's see if Tyler could buy 2 t-shirts and 10 pairs of socks and also spend $45. So the value of T equals 2 represents that Tyler's buying 2 t-shirts at $10 a piece, and S equals 10, buying 10 pairs of socks at $2.50 each. If we do the substitution, 10 times 2 is going to give us 20. $2.50 times 10 is going to give us 25. We want to combine the 20 and the 25. That's going to give us 45. Once again, 45 equals 45, which makes this true. So if Tyler buys 2 t-shirts at $10 a piece and 10 pairs of socks at $2.50, he is going to spend, again, a total of $45.